You're just starting rivers. Okay. How? Okay, apart from, have you been to the Singapore River, Kallang River now? No. Some has, some haven't. Those of you who have been overseas, have you seen rivers? Like if you go to England or if you go to where, Australia or Hong Kong, you notice I'm trying to understand what is your experience of the river? I know you've done this in Sec 1, probably you had a similar experience. You probably had a similar lesson in Sec 1. The problem with rivers in Singapore, okay, let's see. Can anybody think of a problem with rivers in Singapore? They are dirty. For example, what is your experience of a dirty river in Singapore? See, okay, you don't have a concrete example, but you just have an understanding that rivers in Singapore are dirty, is it? Okay. Can anyone maybe move around here? I know you just want to concentrate on your keywords and everything and score well, but trust me, this way you'll be able to understand your keywords better than if you just memorize them blindly. Okay? Because keywords after a while, you look at the size of your textbook. After a while, okay. After a while, your textbook is going to have so many keywords by the end of 2 years, Sec 3 and Sec 4, that you're going to be all blurred, and if you go to the exam and you panic, all your keywords and concepts will be all mixed up. The way I'm teaching you now, the way I'm trying to help you now, is to help you make sense, is to help you give an organizer in your own head about the keywords. So just play along with me, even though it may not make sense to you right now. I'm trying to help you so that when you go to the exam and you panic and you gabra, and you've either experienced it yourself or you still happen to your friends, right? I'm sure. Everything all becomes a mess and you can't remember what you memorized. This way, at least you have something to fall back on so that you can slowly work out what you memorized last time. Okay? So thank you for paying attention to me, ladies especially. Thanks. So now where was I? Yeah. Okay. Any problems with rivers in Singapore? What else might be a problem with the river in Singapore? Are there rivers in Singapore or not? I mentioned Singapore and Kallang River, right? Are they proper rivers or what? What do you think they are? Artificial rivers. What way are they artificial? Huh? So there are concrete walls around them. When you look at your pictures of rivers in your textbook, you don't see rivers which are straight and have concrete walls, right? You see pictures which are all curvy. You can open your textbook now to the proper chapter. You know which chapter it is now. Okay, so the rivers in Singapore, many of them have walls. The proper term for such a wall is so the proper term for such a wall, you can write this down. Which page is the place right now?
Okay, can you turn page? Yeah.
Page what?
1 to 6.
1 to 6. Okay, 1 to 6 is a good place to write down this word. Is it already there? It's already there. Okay, so you put it here. Oh, sorry.
Okay, if you look at page 1 to 6, are you looking at page 1 to 6? Alright, you see that there are different types of ways in which the rivers have actually been modified, right? Okay, what are some of the ways that are given? The one given in your textbook.
Realignment.
Okay, very good. Realignment, what else? Resection. Okay, just looking at, I want to see how you can actually, just reading through your text, you should be able to have an idea what realignment or what this channelization is all about. Okay, can you just briefly tell me what do you think? Okay, just read through that and tell me what do you think you get is meant by resection. Just look at resection first. Then you can have an understanding of what you mean by we put concrete walls around the river. Yes, Richard. Stand up, attending.
You're already around camera.
Yeah.
Prevent flooding.
Yeah, okay. Okay, that is the purpose of the sectioning. So you have brought out the purpose. Okay, but what exactly is the sectioning? What happens? What is the process? Or what is meant? Okay, yes, exactly. Thank you. Yes. Oh, sorry, to you. Yes. So what do you mean by sectioning? Widening and deepening. Okay, so you see, sometimes when you want to learn, like Dr. Lin says, you don't really need to memorize this whole thing. It is a question of understanding. So what we're going to do now is to actually deepen the understanding that you've got through looking at this visual or this 3D, looking at the 3D environment. Okay?
Okay, I think that was a good introduction. Do you think that was a good introduction, considering that we didn't plan it and we were only starting to plan it at 2 a.m. but we both fell asleep. But I fell asleep and she wasn't even awake. She was still sleeping. So obviously we were doing it in our own separate houses, So yeah.
You are so enthusiastic.
But that was a good introduction, I think, because we really didn't plan this. Okay, so now that we've got the introduction to the lesson, let's see what you have to see. Okay. So what I'll do is I'll give you can see or not? Everybody can see, right? Like, you need the lights off, can see, right? Yeah. Okay. What I'll do is I'll give you an overview of the environment here, okay? And then we will go into specifics. Yeah, the slide. So let's see, let's turn on. Okay. So we have a curvy river there, right? Yeah. Can you remember from Sec 1? Do you all study this in Sec 1? Yes. Yeah. Can you remember from Sec 1 what the curve is for such a curvy meander? Okay. So we have a meander. We have a series of meanders, in fact, right? We have a series of meanders, and then let's see. Let's show you the whole map. I'm not sure how fast I've got questions quite fast. Okay. So okay. North, south, east, west. The AMK is here. The AMK is here. You can see the river curving here, right? You can see the river curving here. Just a quick question. In which direction are we facing now?
South. No, east.
No, west.
East. North. East.
Okay. I switch to sunrise, I switch to sunrise. The sun is there, right? So if the sun is there, we are facing east, right? Okay? So, in which direction is the river exiting to the sea? Southeast. You want to see the map again? Ladies, you must try. Ladies, you just keep trying. You will never learn. This is the way this lesson goes is that you must try, and it doesn't matter whether your answer is right or wrong, but you must try to contribute. Okay? So here you can see that the river is exiting southeast, right? Follow so far now? Yes. Yep. Okay. Now, where is the source of the river? It's obviously somewhere there, right? Okay? Let's have a listen. Yeah, she's fly very slowly. She's a very humble person, fly very slowly. Come to show off. Okay, now, in what way is this part of the river, this is all revision from Sec 1, in what way is this part of the river different from that part of the river? It's very obvious, just throw a few keywords. There's a waterfall, whereas down there you don't have a waterfall, instead you have a series of meanders, right? So those are your keywords there, right? Okay? So what else? In what other ways is this part of the river different from this part of the river? The gradient is different. Now, in what? How does the influence of the gradient, or what does the gradient influence? Which aspect of the river does the gradient influence? The speed of flow. What is a keyword? What is a keyword for speed? What is a keyword for speed? Instead of writing speed, it's a word beginning with V. Velocity.
This is now. Ada orang.
Thank you.
Tentang orang.
Oh, gimana lah?
Tentang orang.
So, gradient influences velocity. Not many of you use the word velocity. I only heard the word velocity from a couple of you. If you want to score well in your exam, you have to use the keywords instead of using the normal English terms. Okay, I shall say this again. If you want to score well in your exam, you must use the proper keywords instead of using the normal English terms. So what's the proper keyword for speed? Velocity. What is the other word that is also beginning with V, which is associated with rivers? Velocity and let's see. You want to guess not? Velocity and what? Okay, let's try and guess. Now, here we see a series of. Does anyone want to tell me what these things are? Okay, waterfalls. Any other? Waterfall, definitely. There's a waterfall here. Correct. What else? What other words can be used to describe this? Tributaries. What is a tributary?
Small vein like.
A small vein-like structure. Did you get it from the book? Okay. A small vein-like structure. So veins as in blood vessels, is it? I assume, right? So can you see the veins here? Where are these vein-like structures? Where are the veins? Can you see the vein-like structure? Do you understand what I meant by vein or not? V-E-I-N. Where are the veins? The veins are here. You can see that the rivers are the streams are feeding into each other, right? The streams are feeding into each other. So when streams feed into each other like this, they are known as tributaries. So is there a corresponding picture in your book? I'm sure there must be. Okay, so I hope you can match what we see here with what you see in your textbook so that you understand your textbook better rather than just see it as a flat picture. Yeah, that's a very good picture. What page is that? 125. On 125, we see everybody done the 125 textbook. On 125, we see something that looks like tributaries, but it's not. On 125, no, don't tell. You're not supposed to tell the answer. Okay, let's pretend we didn't hear that, right? So on 125, we see something that looks like tributaries, but isn't. So what is the difference between 125 and this? What is the difference between 125 and this, apart from the name? One is pointing up, one is pointing down. But let's use the proper term. Let's use the proper term in geography. One is flowing. Actually, they're all flowing downstream. Correct. Water flows downstream, right? So that's not the proper way. Which one is feeding into each other? The tributaries or the distributaries? Which one is feeding into each other? The tributaries are feeding into each other. So what are the distributaries doing? The distributaries are distributing. They're called distributaries because they are distributing what? The water outwards, right? And do we see? Okay, I just know
Can you guys take away your bags first? Then we talk.
Okay. Let's have a look at the distributaries, Okay. The distributaries are over here. Now, that is more similar to what you see in 125, right? Maybe if I adjust the date. It's reverse. Sorry. No, it's your. Yeah, I think the projector is here. Go back. I go down a bit. I go down a bit. Okay. Does this look a little more like what? I mean, this is obviously different from the upper course, right? This is obviously different from the upper course.
Yes.
Yeah? But so you understand the difference between tributaries and tributaries? Tributaries distribute the water out into the. Can you see what they're doing? There was a single channel, right? The water is all coming out here, right? Yeah? Then it's going this way, it's meandering along. And then what happens when it reaches? What happens when it reaches here? What happens when it starts to divide? It starts to divide. The proper term, you want to write? The proper term is, okay, yeah, you show a term. Instead of saying divide, we say the channel starts to break. Okay, tell them what's the delta. The delta. Yeah, 1 to 5 is a good place for example. Okay. So the channel starts to break. So, okay, just to be very clear. Am I facing upstream or downstream? I'm facing down. And we know it's down because we are looking towards the sea. Yeah, never about the water. That one I cannot control. Okay, because somebody was saying the water looks as if it's going up, right? But I cannot control, okay? It's the wind blowing the water up. Okay? Yeah. So in this shot we can see both the upstream as well as the downstream part. Right? Okay, now let's get a little more sophisticated. Let's see what else you can see. Let's talk about processes.
Okay, if you look, yeah, if you're able to look at these words, are you looking at the board now? Okay, when you look at these words, gradient and velocity, right? Can you turn to your page and find these words? Where is it? What page? What page do you find this word, gradient and velocity? That was introduced to you. Gradient and velocity or speed. Anybody? Can you just flip through first and let's see? Yes, 111. You sure it's 111? And the what? Okay, what do you call this? Gradient and velocity. In terms of how it affects the river. What do you call it? What are these? Yeah, okay, you are explaining what gradient is. But this whole can be categorized, all these words can be categorized under?
I know how to say.
Under what? No.
That's right. Why do you think Mrs. Ismail put these two words here and these three words here? Why do you think she categorized them this way?
Yeah, related.
Okay, these two words are related and these three words are related. So in what way are these two words different from these three words?
Okay, you are now telling me how does this affect the river, okay? So what do we call this? This group of words.
When something affects something,
Yeah.
when something affects something, and something results in something. So these are the results, these are the effects. Right?
Yeah.
Yes.
What's
So
another
what
word
is
for
the
this?
word? There's a word for
Yeah.
it.
What's the word for this?
Very good.
Sentence. Okay, very good. So you've got to understand, listen, there are certain processes or the certain conditions. If you can understand this, you'll be able to understand how to interpret the question. Understand this? Are you clear? So basically we call this factors, right? Alright, very good. Now, this is the result. Another word for results will be huh? Can you look at those pages? Okay, what page is this? This factors come on page 1? 1, correct? Alright. What about results? Where do you find all this? What do you call this? Marcus, where's the textbook? Take it out, yeah. And look for this. Results. What do you call this group of words? Rather than use results, I want you to give me a geographical term for it. Once you know this, you know what is expected of the question. Yes. You got it? Very good. Okay, you call this landform. Now. Alright, now I want you to look at yours. Just read through her. Now you've got factors, you've got landforms. Okay, what do you think is the relationship? What is missing in this whole relationship? Okay, very good. Okay, processes. Okay, now. Okay, I'm going to ask you to listen very carefully, yeah? You see, without really teaching you, you are now learning. Do you realize that? So you see, basically, if you really know how to do it, you are able to understand the topic all by yourself. Okay. Now, I want you to look, where do you find this word processes? What page? 1? 114. Okay, very good. Now, tell me what are the processes that are involved that are actually affecting this landscape that you see on the screen? Okay, what? What do you think? Okay, before we do that, this particular landscape that I shown this, right? The river, if you want to understand the river, we have to learn it in parts, correct? Yes? So that it be easier for you to manage. Yes? Okay, this part that we are showing on the screen, which part of the river is this? What do you call it? The what? The upper course. Very good. Okay, so under processes, then you've got the different courses. Okay. So can we now complete the courses? You've got one upper course, middle course, okay? Lower course. Okay. Okay, now. What I'm showing you on the screen is the upper course, right?
No, you know.
You want to come down and help me here?
Yeah.
Then you'll be all over the place, right? Alright. Okay, now, what I'm showing you here is the here, this portion here, the lower course. Very good. Okay, now, what I want you to do now is I want you to now look at this landform here, right? Right? I want you now to recategorize this into the various parts. Upper course, middle course, and lower course. What kind of landforms or features are found in these various parts of the river? Then we will tackle it part by part. Yes? Understand this? You cannot do a mixed up or confused. You got to look at it in series, right? In sequence. Okay. What will be the features found in the lower course? Since I'm looking at the lower course. What is it? What do you see on the screen? This is called? This area is called what? The river mouth. Okay, are you looking at landforms? Is that a landform? Or is that a characteristic or a feature of the river? The mouth is a landform? What is your understanding of a landform? What do you mean when you say, okay, a landform? What does it mean, the word landform? It is result from factors or processes. Okay, very good. Okay, now. So now you tell me the word mouth, right? Okay. Is that a resultant of anything? No, right? So what is it? It is a natural what? Okay, it's an exit. Okay, fine. That's what the mouth of the river does. Okay, very good. What else? But how different is it from, let's say, a landform? What's the landform here? Here, let's say. What is landform from at the lower cost? Delta. Okay, very good. So now I am going to put here delta. Okay, you say it. Okay, delta. Okay, yes. But under, okay, now we have to still this question now. Okay, you all mentioned now. So, does it matter at all? What is it? It will come under what? What is the term that we're going to use? Does it come under this part of the river? Or does it come under effect or factors? Or does it come under landform? Or does it come under process? It comes under the causes or the features or the labels or the identification of parts of the river, right? So basically when we're looking at causes, it means parts. So you say the mouth, which part of the cause do you find the mouth of the river? In the lower cause. Okay. The girls, have you got a mouth? You want to learn how to interact. Like I said, if I'm too fast, you got to stop me and say yes, this is not yes. Okay, excellent point. Because it is only when you're actively engaged that you are learning. Yes? Okay, that's the reason why I need to learn. Okay, besides the mouth of the river, what else do you think? Okay, let's start with this one. Okay, we're going to go over. Okay, how are we going to do this? We start with cause, factors, landform, or processes. Which one should come first? Which one are we going to learn first? We're going to learn cause. Okay, we're going to do this at the first part. After you do the causes of parts of the river, then when you go into that, I hear you. The factors first, okay, if you want to. And then from there, the processes. Why do you need to know the processes? Okay, when you know the processes, then you can understand or determine whatever. Okay, very good. Okay, so this is the way you can do it. Alright, now, once you got the lower, is that all the parts of the river mouth? The lower course of the river? Is that all? What else have you got here? Is there anything else? Distributors. Is that a landform or is that a feature of the parts of the river? All rivers have distributaries. Okay, you say no, really? You say yes. Okay. Yes, I know. Why do you say yes? All rivers have distributaries. Yes. No. You said yes. No, you see, you must learn to justify. I mean, there is no right and wrong in this part. You see, in different parts of rivers, there are certain different features. It is very good that you have differing views. Yes? Because in reality, that's what life is all about. That's why you actually see the natural landscape as this. If I were to go to another island, you will see a different river. Right? But in this particular landscape, you see a different. Yes? Okay, now they explain how or why they think that all rivers have got this. Yes. It's fine. There's no right and wrong in this. Yes. Okay, what is the process that will result in a distribution? Erosion. Is this an erosional feature? Is distributary an erosional feature? Look through your textbook. The textbook is in front of you. There's a reason. Look at this. Is this an erosional? Huh? It's more what? Yes, we should continue. Yes? Erosion and sedimentation. But which one is more prevalent or more common in this part? Sedimentation. Okay. Alright, very good. So now, your lower cost? Yeah.
What do you understand by sedimentation? The deposition of sediments. Okay, so that's another very good keyword to use. Deposition of sediments. Is this found somewhere? Sure, must be right. Which page is deposition found in? 117. Okay. So what are sediments? In simple language, what is sediments? Rocks. Good. No need to go and check your textbook. In simple language, what is sediments? Examples of sediments are rocks, sand. Okay, so you get the general idea, right? Mud, sand, rocks, pebbles, stone. Where do you think the river picks up the rocks, mud, sand, sediments from? From the river bank. So it picks it up as it works its way downstream and it deposits them here, right?
Yeah.
Okay? So when a river picks up sediment, what is the keyword called? When a river picks up sediment, say it picks it up from the river bank or it picks it up from the upper course, picks it up from here. What is the keyword for pick up?
Marcus, yes. What is the word? Come on, you just say it.
Transportation. Okay, that's a good. Okay, thanks, Marcus. Transportation is not. Okay, transportation is transporting. What do we mean by transporting the sediment? What do you think the river is doing when it transports the sediment? Sorry? It's moving from the. Okay, so when the river transports sediment, what do you mean when say you are in the mass rapid transit or transport? You are being moved from one place to another, right? So the sediment is being moved along the course of the river. But I'm looking for something which is pick up in the first place. For example, I get onto the MRT. Whereas transport is I'm already on the MRT. I'm already on the MRT, so I go from Ang Mo Kio to Bishan. But what is the keyword for getting onto the MRT? What is the keyword for a river picking up the rock?
Yes, make care, what is it?
Erosion.
Okay.
So here we have three very key processes which this is how we're now elaborate on.
Okay. Where do you want to start? From the erosion, transportation, or deposition? Which one? Where do we start? From where? Erosion. Okay, Marcus, where do you think you want to start from erosion? Okay, what about the upper course? Okay, very good. You must start from erosion. Why?
Erosion more than forms.
Okay, from the erosion, then what you get? What if there is no erosion? Can it be possible for other processes to take place? Why not? Huh? Okay, very good. So you see, in the first place, the river got to do erosion first, right? So the first thing, where do you think that will occur? If we are to look at this landscape, where will erosion actually take place? Everywhere. Okay, very good. But where will it be most common? Or easier, upper course? Why?
Because the water is moving at high speed.
The velocity is, so the erosion now is related to your velocity. Is velocity the only elements that will affect erosion, transportation, and
Radiant.
what else?
Radiant affects the water.
Gradient also affects velocity. Okay. What else besides gradient and velocity?
What was the other V word? I was trying to get you to think of a V word. Velocity and it's a common English word.
Yeah.
It's a common English word. It's not a geographical word.
Volume, very good. Where do you think the volume come from? Volume of what? I'm talking about volume.
Water.
Volume of water. Okay. Where does the volume of water come from?
Rainfall.
Alright, now, you understand this? So basically, the factors, the two main factors, right, which affect river processes are Jeanne? The volume of water and
Velocity.
okay. Then gradient, how does it fit into this volume and gradient? Is it another main factor or is it part of this factor? Part. Okay. Gradient affects which one? Velocity. Why? Okay, the steeper the gradient, the greater greater the speed, it will affect which one? It will affect more of the erosion. Actually, it will affect everything, right? But basically, in order for the river to erode, it must have both volume and. So you see, if you were to look at this landscape, alright, is there velocity here? Yes. Yes or no? That's all. Yes. How do you get the velocity? Look at this landscape. How do you get the velocity?
What results in it? Why what is it?
My question is, how do you get this river to actually be faster? Okay. Okay, gradient, very good. What is the gradient here? How do you describe the gradient? Steep. Okay, so in other words, okay, now there is talking about two things. We're talking about steepness by gradient. So this is now becomes, okay, this is what? This, right? So this is A, will be gradient, and you say the gradient will then affect the steepness of the what? The slope, right? Okay, the steeper the slope, then the greater the velocity and the greater the
erosion rate.
isn't it? So you got to see this in parts. This one will then affect it.
Okay, those of you who are not participating, those of you who are not participating, you must participate because what is being mapped out here is the way your answer must look like in the exam. And if you don't participate, your plan is to just memorize. It won't work because there's simply too much to memorize. We are trying to help you realize that actually you don't need to memorize so much because a lot of it is common sense. But you can only realize it's common sense if you participate. If you just plan to quiet and memorize, you could, but you won't get your A. It will be very much harder for you to get your A. Okay? You all pick physics. You all pick pure physics or hard physics or no physics at all? Or physics not?
Pure physics.
You are physics. Okay. So I'm not a physics teacher, I'm a geography teacher. But I'm very sure that sooner or later in your 2 years here, Sec 3, Sec 4, you will learn something called potential energy and kinetic energy. Have you learned that yet? Potential and kinetic energy. Primary school. Okay, so good, excellent. You've already learned it. Somebody sabo you all, huh? Actually, you learned it in primary school. So over here in the upper course is your. Can you describe the energy here in terms of potential and kinetic? High what?
Gravitational.
High what?
High gravitational
Oh, so high gravitational potential. Why is the potential energy high? Why is the potential energy high?
higher.
Because it's altitude, right? It's above sea level, right? Yeah. Then what about kinetic energy? Kinetic energy is obviously high, right? Okay. How do we know that kinetic energy is high? Because we can see the velocity of the river, the flow. If you put these things into your exam script, you will distinguish yourself from those geography candidates who don't bring in the physics knowledge. And then the marker will like what he sees and will get you your marks. About it, as either you want to talk about running or you want to talk about cars. I think running is more gender neutral, okay? So let's say we are trying to run, Now, how fast I run depends on what? What are some of the factors influencing how fast I am able to run? My own energy, right? How much I eat for breakfast? What are the things which help me speed up my energy? What are the things which will slow me down despite the fact that I'm trying to run very fast? Friction from where? From the ground as well as from, if I'm running, it's from the air as well, right? But here, let's look at the river here. There's sources of friction in the river channel. From where?
The sediments.
From the sediments, which is from its load. The word load in the river textbook. The word load is not, but it's there, but it's not there. The word load is not there. Yeah. So is the word load in the textbook? Okay. Sediments we used just now, right? you can actually also use word load. So this is another word for you to write down. I'm stupid because I done the block. Okay? Sediments, or settle, it's called load. So what does a river carry? A river transports its load. Okay? A river transports its load. What does a river deposit? A river deposits its sedimentary load. Okay, fine. Okay. So you all know the word load. So now, so friction comes from the load. Because if I'm carrying a lot of things, there'll be all the load will be banging against each other, there'll be friction, right? So the water will slow down, right? Where else there's where else? What are the other sources of friction from a river? The water is trying to flow very fast, but there's friction. Where else is the source of friction? Never mind. Where else is the source of friction? Okay. And the wind, not quite what I was hoping for. The rocks itself, meaning the ground itself, right? For example, just like if I'm running, I mean the reason why shoes are designed this way is because they're designed to have friction, right? Otherwise it goes slipping all over the place. So when the river is flowing down, there's friction which is trying to slow it down, as well as the gravity which is giving it acceleration. Yeah, right. Okay, there's opposing forces, just like physics. It's very physics, huh? Okay, there's opposing forces. Okay, so to complete Mrs. Ismail's question, what is another factor influencing velocity? What have we just been talking about? Friction. Apart from gradient, another factor influencing velocity is friction. And in this case, the friction comes from the different colors. Why you don't Sorry.
Okay, you got friction is characterized by what? Friction is affected by what rocks?
Yeah, okay. As well as the channel roughness. Okay, we call it channel roughness.
Okay, are you ready to start somewhere? What page will you write it down on? 111. Is that right? Alright, then what's the other one that's missing here? The friction is also caused by the volume. Is it a volume? Will the volume affect water? Will it cause friction? No. You look at page 111. Load we have already talked about. What's the other one? What's the other factor which affects? The energy. Okay, we have talked about that. But what else? Can you look at page 111? What's the other one? What? Yes. The parameter of what? The weather parameter, which means what?
Where does the friction come from once again? Where does the friction come from? The friction comes from the load. Okay? So, let's say this is the load. The load is moving along in the channel. Good. The load is moving along in the channel. The load is moving along the channel, right? Okay. So let's draw in the channel. This is a cross section. Can everybody understand what this is? Yes. The load is moving along in the channel. This is a cross section. Now, okay, let's try to put the whole thing together. Let's try to put it together. This is my school bag. This is my school bag. Now, if I were to put right now my school bag for my Mac, I got my iPad. Okay? My iPad from the new one, Anyway.
So fast.
Anyway, fine. So now I got two computer inside here. Do you think I cannot? Okay, this is obviously a question. Right? I can run fairly fast, right?
Oh.
Okay, I can run. Okay, what happens if I'm going to carry Mrs. Ismail's big stationary box with me? I will slow down, right?
Oh.
Yeah, you play along lah. Okay, if I carry the table, I will slow down, right? Yes, I will. Because why? What has happened to my load? What has happened to my load? My load has increased. My energy is the same, right? My energy is the same, right? But my load has increased. So I will slow down. Right? I will slow down. Now, what did I just do? This is very interesting what I just did. I did it subconsciously. So when I'm tired, what did I do? When I'm tired, I let go of the load. So what is this called in geography? When a river lets go of its load? The position. Why does a river deposit? Because it is trying to, exactly, yes, it is trying to balance energy with load. It is trying to balance energy with load. How does the river get more energy? How does the river get more energy? No. No, let's be serious. No, Mrs. Schimmer has good points to make. I'm just trying to help her. No, let's be serious. What? This now I know your name. Now, what influences the reverse energy? We've talked about it. What? Velocity, thank you. And the other one is volume, right? Okay? In turn, what influences volume? We talked about it here. For. And what influences velocity? We talked about it here. What influences velocity? Gradient and friction, right? Yeah? Can you name it? I think you can see up. Right? Now, the more energy it has, suppose I got a lot of energy, I got so much energy, then I will start to, what will I start to do? I will either start to go very fast, or I will start to pick up more and more things, right? Because I'm going faster and faster, because I'm trying to balance my energy with my load. But the more tired I get, the more I deposit, until eventually I got nothing to carry, and then I stop because I'm so tired. I got no more energy. Okay? Okay. Now, all this thing came about because of something called method perimeter. So, and there was a confusion between vector perimeter and volume. There should not be a confusion between vector perimeter and volume. Perimeter is, as one of you correctly pointed out, perimeter is the what did you say? I used the word. No, you didn't use the word size. You didn't use the word shape. The boundary, right? I think one of you used the word boundary, right? Or the outline or something. I can't remember what you used. Okay. So it's the wet part of the outline. What color is the wet part of the outline? Okay. What color is the wet part of the outline? Is it black, blue, or purple? Purple. The purple is the vector perimeter. Maybe you all must understand this, guys. You all also. The purple is the vector perimeter. Do you understand? Can you see it's the perimeter? Yes. Can you see it's wet? It is called a wet. It is a wet perimeter. Now, why is the vector perimeter important? Because what does the vector perimeter do for your energy? What does the vector perimeter do for your energy? Compare this with this. Which one do you think will be flowing faster? The first one or the second one? Which one do you think will be flowing faster? Whichever.
Very smaller.
Okay. Which one has more friction? Which one do you think that the river is encountering more
The
friction?
one bigger surface area.
Greater surface. Yeah. So in this case, the one with the longer the vector perimeter, the more the friction. The longer the vector perimeter compared to the it's actually a ratio. It's a ratio. The longer the vector perimeter, generally speaking, the more the friction. Is this making sense? The more rough, the more ground there is, the more there will be friction, right? So the longer the vector perimeter, the more friction there is, right? Yeah? Now, what happens is, so, I'll just come up because of time constraints. I want to illustrate this is last week. I really do. I'll just tell you, I'll spoon feed you something. This is the upper course. And this is, generally speaking, more to do with the middle course. Okay? Either upper here middle. But this is a very weird thing. Because why? What am I actually saying now? If I say this is the upper course, and I say this is the middle course, what am I actually saying? The middle course travels faster. But it's not. Intuitively, there's something wrong with that, right? Intuitively, there's something wrong with that. The middle course is traveling faster than the upper course. Now, let's go about solving this problem. Why is the upper course? What is the problem with the upper course? The problem with the upper course is, yes, it is very steep, but is it a very efficient channel? It's not. It's not an efficient channel. It's not an efficient channel because there's so much friction. So one of the factors is very big, but the other factor is just as there's a lot of gradient. Gradient is very high, right? High gradient, steep gradient, right? In the upper course, it's steep gradient, right? You can see.
Yes.
But you can also see that there's a lot of, because the channel shape looks like this is a deep V-shaped valley, there's a lot of friction as well. So it is not often as fast as it might appear. Okay? So actually, that's a good question. Okay? I haven't. Okay, I used to be able to teach this very well last time when I was teaching in secondary school, but I haven't taught this lesson in many years, so I'm a bit rusty. The other problem with the upper course is that there's a, okay, let's see, what are these? Stones and rocks, right? Boulders, right? Yeah? What do you think they do to the vector perimeter? What do you think they do to the friction and the vector perimeter? They increase it. Because the river has to expend energy getting over it, right? So, in the upper course, there's a lot of rocks which have not yet been eroded. The rocks have not yet been eroded. Are they part of the load yet? No. They're not. What is load? Load is what? Load is if you're already transporting it. If you're already transporting it, it's load. But is this cable load, is it stationary? It's not. Only if I pick it up, then it becomes my load. No.
Yes.
Okay? If I pick it up, it becomes my load. But is this loading me? Is this slowing me down? If it's just like that. Is this slowing me down? It's not slowing me down, right? Common sense tells you it's not slowing me down, right? But if I pick it up, will it slow me down? It will. So, now, wait, Mrs. Miles is a very good teacher. You look at how many colors she has in her bag. Okay? Now, what does the presence of the boulders do to the vector perimeter? It increases it even more! Look at how the vector perimeter has suddenly increased! So, actually, can you see it's so narrow now? You think the water can flow very fast through here? Honestly not, right? Cannot, right? Okay? So, yeah. Now, but then there's something, but then there's something really weird. There's something really weird. is why does the river start to deposit in the lower course? Okay, why does the river start to deposit in the lower course? Why? Okay, why does the river deposit? The river deposits when its energy is the energy load balance is what? Which one is greater? Energy or load? If I'm no energy already. So it means I'm carrying too much load, right? I'm carrying too much load, so I deposit, right? Either I'm carrying too much load or I have no more energy left. So something around here is causing either the energy to fall or the load to increase, or maybe both. Something around here is causing either the energy to fall or the load to increase, or maybe both. That's why it's depositing all this. Can you follow? Honestly, can you follow? This is all deposit, right? These are all the tables being put down, right? Yeah? Why? What is it? What is it about this part of the river? Because we say it's a very efficient channel. We say it's a very efficient channel. But something happens here that makes the energy, that makes it lose energy, or that makes the load suddenly go up. What might it be?
Gradient.
The gradient, okay. So the gradient, once again, so this time the gradient is very low. So once we have low gradient, we have lower energy. Okay. Now, something that we haven't discussed yet is what do you think is actually happening here? Here. The water is coming. And then what do you think is actually happening here?
Go into sea.
Second,
Go
it goes into the sea. Now, is it so straightforward as that? Supposing we have a big, you go to the toilet, you have a big sink. Okay, now I know your toilet has a big sink, but supposing you have a big bathtub in your toilet, and then you have a pipe you have a hose, you have a water hose. Now, you put a water hose into your big bathtub which is already full of water. You put your water hose, you put your water hose into a big bathtub which is already full of water. I want you to describe to me what you think is happening when the water from the hose hits the big bathtub. But overflow means why would it overflow? Because it is what? Why does the Bukit Timah Canal flood? Why do we get flooding on Jurong? Because I tell you, yes, good. So because you have your very speedy, efficient middle class here, right? Do we all agree that this is speedy and efficient? Yes? So it's coming out, and then suddenly it hits a big bathtub called the sea. It hits a big bathtub called the sea. So what do you think happens to the velocity? It goes all the way down. Because supposing I'm running, I hit the wall. If I hit the wall, I have to slow down, right? I can't just go through the wall. I'm getting tired. So your velocity will go all the way down. So what happens if your velocity goes all the way down? Your energy also goes all the way down. So if your energy goes all the way down, you will start to deposit the load. Now, is this making sense to you? Yes. Okay? Okay, Okay. Now you continue.
Okay, now let's just summarize that. In terms of velocity, what are the factors? Then we just look at 3 factors. What are the 3 factors? Gradient, friction, and volume. Method perimeter. Okay, now let's look at volume now. So are you ready? When we find volume factors, volume affecting river, which page is this? Which page? 112. We're looking at page 112, right? We're looking at the volume of the water, right? Yes? How does the volume of water affect the river processes? What what are the contributing factors or reasons why? How do you get volume of the water? When it rains. So one will be, we have already said here, right? The amount of rainfall. Yes? You understand this? Yes? Okay, now when it rains, you look at this. If you look at this channel, okay, let's say we start from here. Alright, this, let's say the rain will fall on this area, right? Okay. Now if we can, the water or the rain will fall onto the slope, yes, and ultimately will let us imagine, okay, let's say imagine this whole area from the, what is the beginning of the river called? The beginning of the river. Okay, so river source, right? Okay, so we will put it under which one? Upper, middle, lower? Okay, so we have the source. From the source, okay, let's say imagine, okay, I'm just going to tell you to imagine. From the source, the rain is falling from the source, goes through the middle course, and then it ends up at the mouth of the river. So you will find that if the river is, let's say, flowing, okay, Dr. Lim will come in. Let's say, I'm just going to draw from the top, right? Okay. I just imagine it goes from here, and then it goes down, it goes through, and then it goes meander, and then it will go to, what is this one? Okay, this portion, let's say this is the okay, this portion here, more or less will be your what? Which part of the river is this? I'm looking at it from the top, between this and this. From the top, if you're looking from the top view, right? So this portion will be your upper course, this portion will be your middle course, and then as you go towards and then it will end up in the where this portion here? The low course. So do you understand this? So basically now you have actually gone through, you are going through a filter, right? You've gone from the mouth of the river, go through the middle course, and then ending off at the river mouth. Okay, now, when the rain falls, right, in this area, right? Correct. The river will then, what does the river do? It will flow. It will carry the water, right? The volume. Now, when it falls, this river is enclosed by, how does the water from the rain falls into this river? It must go through what? Will it just go through and then flow downwards in a very massive avalanche of water? So how does it flow? So usually a river will be enclosed by what? By a basin. Now the basin is enclosed by, okay, imagine, let's say this is the river, right? Okay, imagine this. Look at this. What do you see along this river channel? Okay, you look at this. Okay, you look at this picture. You look at my screen. Okay, your screen there. Okay, I'm going to go through again. From the, now it's the other way around, from the river mouth, right up to the river channel. Are you ready? Okay, you look at, I want you to look at the surrounding landscape in which the river is passing. Okay, you understand this? So if I were to look at this, okay, you look at this river here. Let's go to this up. Now, if you look at this part of the river here, okay, so here I'm doing this vertical filtering. Okay, the river now. Okay, look at start with an L, what do you think it is? Low what? Low, not low velocity, okay, not low velocity, but low line area. So this is the term which you must. Can you look at this portion here where you have the, like this word, gentle gradient, low line area. Okay. So the river, the surrounding area here is gentle. What else can you describe this portion? Any other words? It's a gentle gradient, low lying, what else? Basically this one. What other words can you describe it? Flat, very good. Flat as well as flat and what? Look at this, look at the expanse of flat.
Flat and wide, right? Flat and wide.
Flat and wide. Okay.
Broad. Flat and broad.
Okay, you understand this? Alright, so we can see that when we map it out, probably we'll say this boundary of this river, right? Correct? You notice that basically our strength here is very broad. And you find that basically there is very little what? Very compared to the higher compared to the high upper cost. Compared to the upper cost. Can you describe it as hilly? At this portion river. Here at the low cost. Can you describe it as hilly? Yeah, hilly means there's a lot of fields. Are there a lot of fields? No, it's flat, broad and wide. Yes? Okay. When does it start becoming hilly? When do you think? Look at look at this like starting from the middle cost. Okay, so probably here there's more hills, right? Okay, I'm just going to use a line to represent the start of a hilly area. Okay, probably I will use another color. I will follow the
Actually, we can actually walk to the line. Let's go to the line, huh?
Okay.
Let's go to the line and stand on it. Okay. So. Yeah, okay, I can't control the way it walks, alright? Okay, now, can you see that? Yes.
So you're somewhere here, right? Yes? Okay, there is a whole stretch of
Whole stretch of line, huh? Yeah.
yes, you know what you call it?
There's a word
Is it?
for this.
Yeah.
Peak.
Yeah, you are at the mountain top, but it is not just one point, it is a stretch of mountain, right? What do you call it?
Begins with W. Oh, okay. It begins with R. Very close to range. Very close to range. No.
No.
Hangman.
Ridge. This where we are walking now is we are walking on a ridge.
Okay,
So describe the ridge to us. Describe the ridge to us. It's long.
okay.
It's dangerous. Okay. And why is it dangerous? Why is it dangerous? It's narrow. Okay, you need all these words, huh? You need all I'm not just saying these words for fun, huh? It's long. It's narrow. Why else is it dangerous? It's uneven and if I jump down, I won't be able to show myself. I could fall down. We need to find a really steep up. Yeah. So the other word was also steep, right? Okay, we need to find a really steep path. Okay, I tell you, you want me to fall down, right? I was down. Okay, so now where am I? Now you continue.
Okay, we are now at the ridge, right? Okay, now we're going down. From the ridge, okay, now we'll slowly go down. So straight on down. Right? Now you're looking at the ridge, now we want to look at the valley. Right? Okay, so here you see this line, I'm drawing here. It's long, right? And then you see, can you just sketch What do you call that river then? Or that one flow of water? What do you call that? The what? The tributaries. Please don't confuse between the tributaries and so you, yes. So you notice that it is actually here, if I was actually kind of draw the sketch, I will have like 3 rivers flowing down, right? Yes? Are you all following me? Okay, let's say I'm just drawing this like that. Okay. Now this meeting of the rivers at one place, what do you call it? It starts with a C. The point. Yeah, point where the rivers.
This point here where the rivers.
Conjunction.
Good guess.
Okay, connection. Okay, this is a connection. Yes, but we want a geographical term. Okay.
The part where the river joins up, where the tributaries all meet.
Yeah. Okay, I give you a clue. Okay, we start with C. Okay, so we have said connection. Okay, start with C and
Conjunction, that's another good guess, perhaps not.
okay, I give you another word. I'm sure you have heard of it.
Convection.
Convection. Yeah. The distributor is Marcus here, right? Convection. What is that? Come on. You know this.
Confucius.
Come on. Okay, next word. Okay, let's see. UNFL.
Conflict.
Oh, very. Oh, no,
Conflict,
conflict. You all started social studies already, is it? Have you started social studies yet?
Oh, yes.
I wrote in social studies section, I was not the writer, so you don't like it.
Okay, what? What's it? Yes. Yes. What's the word? Say something here. Con what? Con what?
Persuasion.
No. Okay, I'll give you another clue.
Yes,
Con flu.
Confluence.
Okay, very good. Con flu.
Yeah, I'm not
Right?
right.
No, these are terms. Can you write it? It's not in your text, but can you please write it? Because just in case the examiner decides to use this one, then you will be at a loss. Okay.
or you can use it in your essay and converse.
Yeah. Can you?
They are
Okay,
showing
one
you the
page.
converse, they are showing you the converse, in case you don't know what it is.
What page do you think you should write it? Where? Where will you see this? Come on. 109. Just 109. Let's see what it is. 109. Yes, you see it? Okay, very good. Okay, got it? Okay, now you notice that when the water flows, it must be flowing down, right? And then we must follow what? Follow what? When the rain falls, it will follow the, not only the wind, but we will follow what? How does it flow in this area? It flows through the channel, but before it flows into the channel, where does it flow first? Okay, ground, very good. So in this case, the ground is this surrounding area that Dr. Lin is showing you, right? Correct. Right, so let's say I map out this ground that you're talking about. Huh? Okay, so imagine I'm drawing this position. Okay, so it will probably go around the river, right? Yes, it goes through the, I'm just doing a rough thing based on what is here. And then it ends off at the river mouth. Right? So whatever rain that falls, it will fall on the ground, whether it is a steep slope that you have actually recognized, and then it will flow through the hilly areas, and then into the flat ground. What do you call this portion? This area that is actually sandwiching the river? It's called a sandwich. It's called a what? This at the lower class, what do you call this? This whole area is called the boundary, the red boundary that I've drawn is called the wisely, was it? Wisely? Just now? Is that what you say?
For the whole area.
Okay, drainage.
It's the catchment area. It's the area where the river gets its water from. Okay? So, it's the area where the river, today's river, right? Today's river, right? Okay? So today's river into the river, eventually flow into the river, right? Any rain which falls on this side of the mountain will eventually end up in the river. So this is the drainage basin for this river. This is a catchment area for this river. Just like Ang Mo Kio has a catchment area, and so on and so forth. Okay?
So what page do you find this word? It comes under what? Under what page? What page is catchment area or drainage basin? Huh? One? Very good. So you notice we have covered a lot, right? Yes? So what have we covered? Okay, give me broad terms. What have we covered? Summarize. First, before factors, what do we actually recognize?
Landform.
Straight away landform. Have we covered most of landform? No. We have covered some parts. Okay, what do we cover first? Let's do in sequence. The causes or the cause of rivers, right? Okay, how many causes have we got? 3. Basically, what are they? Upper, middle, and right horn. Are we in class? Yes, thank you. I just give me a few minutes to sum up. Come on. Okay, what is it? Again, causes? Upper, middle, and lower. Very good. Then we go into factors. What are the factors? Broadly? Not really the main factors. Velocity and volume. Very good. Okay, then from the factors, where do we go to? Is it landform straight away? Okay, the processes. What are 3? How many processes? How many processes? 3 processes. What are they? Amanda? Okay, there are 3 processes, right? Erosion. What else? Deposition. Transportation and deposition. And lastly, this will then result in your landforms. For example, yes, waterfalls, tributaries, drainage, and so on. Okay, understand that? So do you notice that with this, without actually looking at text, we have covered a lot of the very many pages of the text. Notice we have covered from 111 up to about delta is what page? Delta. So basically we have covered, we have sent through your text, right? Okay, next lesson, are you listening? What are we going to cover?
Other concepts.
Is it in fact, we have covered this, right? We have basically covered here. Yes? We have covered, have we covered factors? Yes. So what is left? Basically, we have to cover here, this portion, and processes in detail. And then we will go to the landform. Understand that? Okay, clear? So you find that actually learning is not so that bad, right? Even a lesson, right? 1.5 hours, you can actually learn a lot. And without really plowing through your text. So you've got to be active in your learning. Yes, Mr. Ryan Horn? Yes? Okay. Alright, thank you very much. I'll see you next week. Make sure you do your work. Yes, I will return you Christian. Collect it later. Okay, next class.
Everyone, I would like to thank you for your patience today. It was successful because of you.